My name is Nathaniel, and I'll be doing question 1 for exam 3. So to start off with, part A asks, some airliners use wires of aluminum with for resistivity of 2.75 times 10 to the power of negative 8 ohms times meters. So just write that down. P equals 2.75 times 10 to the power of negative 8 ohms meters. Rather than copper to reduce weight, the potential difference between the ends of aluminum wire, which is 33 meters long, so length equals 33 m, and has a 1.5 volts, so 1.55 volts. So V equals 1.55, and the wire carries the current at 1.2 amps. So I equals 1.20 amps. It's asking to find the electrical field magnitude. So to find the electrical field magnitude, we have length and we have volts. So we could just use a simple formula where volts equals electrical field times length. Since we have length and volts already, we just use algebra to move L to V and leave E by itself. So that'll be E equals V over L, and that'll equal pretty much 1.55 divided by 1.22. That's wrong. I meant 33 meters. So putting that in the calculator, that'd be 1.55 divided by 33, which is 0.0469. So that'll equal the volts M equals 0.0469. Repeating right there. V over M equals E. That's for part A. Part A. That's electrical field. If you want to make it bigger, or like the multiplication, 4.69 times 10 to the power negative 2 V slash M. So for part B, it's asking to find the resistance. Finding the resistance isn't too hard since we already have the resistivity, the length. Actually, no, it's not that. To find the resistivity, all we have to use is voltage and amps. And since to find voltage, you use V equals amps and, well, the current times resistivity. All we have to do is move R by itself or just move I away. So that'll just be simply R equals V over I. V is 1.55 over 1.2. So just equal 1.29 ohms. That's the resistivity right here. R. And that'll be for part B. And now it's asking to find the cross-sectional area. And to do that, all we have to do is use the formula that we could also use to find resistivity, which would be R equals pretty much P L over A. And so all we have to do is just move A2 by itself, which is area, which is very simple. All we have to do is multiply both by A. So that'll be pretty much A R equals PL now, and then divide by R. That'll be R equals PL over R. A equals PL over R. A. Just a little bit of algebra like always. And all we have to do is plug everything in. The resistivity of the wire is 2.75 times 10 power of negative 8 ohms meters over, well, actually didn't do also length, which is 33 meters, and resistivity, which is 1.29 ohms. Just do all the math right there. That'll equal to about 7.03 times 10 to the power of negative 7 meters squared, because meter right here, squared it, and this cancels out. Just multiply all the numbers together and divide it right here, and you just get 7.03 times 10 to the power of negative 7 cross-sectional area. A equals that. For C, part C. Now part D to E, this is gonna be, let's just do this, D to E. We're gonna use, it's asking that when a current of 0.218 amps, so I equals 0.218 amps, it is present in a wire with 23 meters long. That is 23 meters long. 23 M equals L. With a cross-sectional area of 8.19. 8.19 times 10 negative 7. 10 to the power of negative 7 meters squared equals 8. The electrical field in the wire is 6.5. So E equals 6.50 times 10 to the power of negative 3 volts/meters. What is the resistance of the wire? To find the resistance of the wire, we first have to find voltage. Since we know let me show you real quick. So to find resistance, we're gonna have to get R equals V over I. Well, we don't have V, but we have current. We have I. So to find volts, all we have to do is V equals the field times length. We have length, we have field. Multiply them together. So that'll be 23 M times, what was it, 6.5 times 10 to the power of negative 3 volts/meters. Multiply that together, you get a value of 23 times 6.5 times 10 to the power negative 3. So about 0.15 volts. That's what it equals. So now we have volts. We found the resistance. All we have to do is 0.15 over the amps. Amps is right over here. That'd be 0.218 amps, which is going to equal 0.15 divided by 0.218, around 0.69 about. That's the resistance, ohms, about 0.69. Or more accurately, 0.688. So like that. And yep, that's the resistance. Ohms right here. 0.688 ohms. What is the resistivity of the material of which the wire is made? Since we have all this, all we have to do to get the resistivity, hold up, let me do the formula real quick. To find resistance, you use R equals, you could also use P L over A. And then just gotta move you gotta move P by itself. So all we have to do is pretty much divide it by this right here. And that'll move it to R. Well, P equals A R over L. And then we just plug everything in. Since we have area is 8.19 times 10 power of -7 meters squared over, what was the length? The length was 23. And then don't forget resistance. Resistance is 0.688 ohms. So we just plug everything in and we get about P equals 2.46 times 10 to the power of -8 ohms times meters. There's ohms here, meters, divided by meters, get rid of the one right there. That's the resistivity of the wire. Now we're gonna go to part F2I. Let me just do this. This is right here, this is E. This is the answer for E. And this is the answer for D. Now part F2I. It's asking. There are two wires of circular cross-section are made of the same metal. Wire 1 has a radius of R. So wire 1 is going to equal, has a radius R. So radius equals R. Well, R, small r. And length L. Length just equals L. Now, wire 2 has radius equals 2R. Length equals 2L. The potential difference between the wires is the same. So V equals So V equals the other V. For both wires, find the ratio of the resistance of wire 2 over wire 1. So R wire 2 over R wire 1. This equals, it's not going to be too hard. So to find the resistance, we have pretty much length and area, and the resistance between the wires are the same actually. So instead of V, it's P. So P equals P. So it'd be like that. So all we have to do is use our formula to find pretty much resistance, which is using pretty much these values that we have. R equals, well, put it below this one. R equals PL over area. So length, resistivity, and area. So since wire 2 has 2R and length of 2L, to find area, since we don't have area, we have radius. We just have to use the formula for area of a circle, cross section. That'll be pretty much, area is gonna, hold up. Area equals pi r squared. So that's the area. All we have to do is plug it in to make it equal each other. So that'll be P equals the same, P equals the same. Hold up, let me put it like this. P equals the same. Wire 2 has 2L and a radius of 2R. I'm going to square this. And then it's the area times pi. That's going to be over PL, which is wire 1, over pi r squared. So now we're going to have to divide from each other. It's easier to just flip it to like the reciprocal. It'll just be P2L over pi 2R squared. Oh, let's just simplify this too. It'll be 4R squared and times times pi r squared over PL. Now, all you have to do is just cross out all the things that are equal from each other. So cross out this, length, and pretty much P, pi. That just leaves 2 over 4. And so 2 over 4 is the resistance ratio, which is just equal 1 over 2. So the resistance ratio for wire 2 to the resistance of wire 1 is half. So let's do this real quick. R wire 2 over R wire 1 equals 1 over 2. Now we just have to find the ratio of the current of wire 2 to the current of wire 1 again, which is the current, not the same ratio. resistivity. So I, that one was for F. So I wait, so I wire 2 over I wire 1 is going to equal, so we just use another formula, very simple. So V equals I R. We just leave I by itself. So that'll be, no, I by itself. I equals V over R. And so oh yeah, the potential difference, like it says, is the same. Oh, the same metal, yeah. V also equals the same. V equals V. I don't know why I crossed it out. I said it right there. So the potential difference is the same. That's why. What's up there? So yeah, V equals V, P equals P, same wire, but the potential difference is also the same. So V equals V. That's why I'm doing this. So I equals volts over R, and we have the volts equal the same. So and the resistance is half of the wires 2 resistance is half of wire 1. So all we have to do is plug it in. So that would be V over pretty much, let's see, 0.5. 0.5 R over V equals R. Do a little quick flip. So V equals 0.5 R, and that'll be R over R over V times cross out, cross out, cross out, cross out. That'll be 1 divided by 0.5, which just equals 2. So the ratio for the current from wire 2 over wire 1 is going to be 2. So I wire 2 over I wire 1 equals 2. For part G. Now for part H, it's going to ask, find the ratio. Yeah, part H. Part H, find the ratio of the current density of the wire 2 to the current density of wire 1. So we're going to have to use this formula, which is going to be E equals PJ, which also equals P times current over amps, not amps, here we go. And so we already have a few things to find J. So we're going to use PJ equals P times I over A, since P's same thing, I is going to be the same. So I'll just do this real quick. So J wire 2 over J wire 1 is going to equal, real quick, we're finding J. So for this, first, we're going to have to move J by itself. So if we divide by J over here, so we grab this part, it's going to be, it's going to cancel each other out. So it's going to be pretty much I I over amps equals P. Very simple. No, equals J, not P. J. So all we have to do to find J, we have the current already. The current is 2 for wire 2, so 2 times versus wire 1. So it's going to be right here, which is going to be, let's do this real quick. So 2I over, no wait, yeah, over the area. The area, as done before, is going to be pi 2 2r squared over I over pi r. With the whole reciprocal multiplication, which is going to equal pretty much 2I over pi 4r squared times I under pi r squared. Let's cancel. This is gonna cancel. It's gonna leave 2 over 4 again. So 2 over 4 equals 1 over 2. That's gonna be the ratio for the current density of wire 2 over 1. So wire 2 J wire 1 equals 1 over 2. And now using the previous E equals P over J, it wants to find the ratio of the electrical field of the wire 2 to the electrical field of magnitude of wire 1. So electrical field just equals P over J, and we already have P, we also have J. J is 1 over 2, so it's going to be very simple. So E equals, E wire 2 over E wire 1. Plug everything in, it's going to be pretty much P, which is the same, 1 over 0.5, hold up, 0.5 J over PJ. And it's very simple, just cut it out. So So 0.5 over 1, that's just 0.5. 0.5 right there equals 0.5. That's going to be for I. And previously this was for H right here. And now we're on to part J2L. J2L. It's gonna be asking the current in a certain wire at 20 degrees Celsius is 2.4 amps. So at T, hold up real quick. At T equals 20 degrees C, the amps are 2.4. Wait, so real quick, I equals 2.4 amps, and then when the potential difference between the ends of the wire is 1.5, when the potential difference. So V equals 1.5 the wire is heated to 80.0 C and the potential difference remains the same, the current decreases to 2.0 amps. So at T equals 80.0 C, I equals 2 amps, but the potential difference equals the same thing, so 1.5. That's what it's saying. What is the resistance of the wire at 20 degrees Celsius? Very simple. We just previously used what we used before. Resistance equals V over I. V equals, for 20 degrees Celsius, 1.5, and then current equals 2.4 amps. V just equals, plug that in real quick, that'll be 0.625 ohms. That's for J. That's at 20 degrees Celsius. So, hold up. Let me just real quick. Equals R 20.0 C. So, for J. For part K, it's asking what is the resistance of the wire at 80 degrees Celsius. So, it'll just be the same thing. We're gonna do, the voltage is the same, so 1.5 over 2 amps instead. So that'll just equal 0.75. Ohms for R 80 degrees Celsius for part K. Very simple. And now it's asking part L, what is the temperature coefficient of the resistivity of the material of which the wire is made of? So we're just going to use the formula to find pretty much the resistance at a different temperature, which is simply R equals R0 times to the, I guess, parentheses, 1 plus A, which is what we're trying to find, the coefficient of resistivity, which is A, and another parentheses, T equals, no, not T equals, T minus T0. All right. Now we're just gonna have to define everything. So the way we're gonna define everything is that T equals 0 will equal 20 degrees. And at T equals just T normal T, it'll just be 80 degrees C. And then for resistance, that's just gonna be, what was it again? 0.75. Ohms. And then for R0, that's just gonna be 0.625 ohms. So all we have to do is just plug everything in pretty much. So Actually, first we could just organize everything. Um, so it'd be R equals now, simplify R, or I can spread everything out. R0 times plus R0A. Gonna be T minus T0. This is just simple algebra again. We're just trying to organize everything to get A by itself. So we could just find A. So we could get the temperature coefficient of resistivity. So that'll just be, we have to move R0 to the left. So it'll be R minus R0. Moving it to the left equals R0A T minus T0. All I have to do is divide everything by, divide the right side that's not A, so it could go to the left side. So it'll be A equals R minus R0 over R0 times T minus T0. So now we just plug everything in. So A equals 0.75 ohms minus 0.625 ohms over 0.625 ohms, and then parentheses, that'll be temperature, normal temperature, 80 degrees, and then minus 20 degrees. 20 C. Put that in the calculator. That'll be about 3.33 times 10 to the power of negative 3 Celsius. Negative 1. Wait, hold up. So wait. Negative 3 over here times 10 to the power of negative 3. And then Celsius is going to be negative 1. Yeah, since Celsius is going to be under, we're trying to get that. Yep. So that's what A equals, which is, once again, the temperature coefficient of resistivity of the material, which the wire is made of. That's for part L. Making sure my calculations are correct. Should be correct, yep. L, that's L right there. Did I put K? K's, yeah. That's K, that's J. Yep, perfect. And that should be everything for question 1 for exam 3. Thank you.